Okay, section 7.1 and 7.2, day 2 notes. How do you write such questions, how do you write a compound equation? This is actually probably more real world. You could actually use this, some of the stuff in chapter 6 probably won't use, but this stuff you can actually use in the real world situations, exponential functions, and solving for them. Okay, exponential growth and decay models for story problems. Pretty simple. Y equals A, parentheses 1 plus r to the power of t, where a is the initial amount, r is the percent of increase or decrease. If it's growth, it's plus r. If it's decay, it's minus r. And that's the rate, and then time is in years. Okay, pretty simple formulas. Okay, think about 1 as 100%, and you're either going to be adding a percent to 100%, or you're going to be subtracting from 100%. So, and then you just got to rewrite it in decimal form. So the first one says in 1996 there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by 0.92% each year. So since it said increase, we know we're going to use the growth factor, which was the plus one. So what we're going to do is, if we just want to write an equation represent this situation, not solve it yet, we're going to write it as y equals a, which is the initial amount, which is 2,573, parentheses 1 plus the incident or the percent, which we changed to a decimal, 0.92. Okay, and we're just going to leave it right now to the power x, because I know it says 7 years, but we're not solving it yet. We're just trying to write a situation to represent it. Okay, and that could be any years. If you want to find 8 years, you put in 8 for x. 9 years, put in 9 for x. Then how many incidents were there in 2003? Well, 7 years from 1996 to 2003. So now we know we could put in 7. So we can simplify this and go y equals 2,573. 1 plus 0.92 is 1.92 to the power of 7. Okay. So 2,573 times 1.92 to the power of 7. You can put that straight in your calculator and get your answer. I'm actually going to do that real quick. 2,573 parentheses 1.92 to the power of 7. Enter. And we get 247,484. Okay, 0.7182 approximately. Okay, so we can round that to 485. Okay, so let's write that number down. There were 247,485 incidents. Which makes sense because wasn't much internet or computers in 1996. Now there were 10 in 2003. Okay, let's go to the next question. A new snowmobile costs $4,200. The value of the snowmobile decreases by 10%. Okay, each year. Write an equation. Well, this time it's going to be decay, so we're going to write y equals a, which the initial amount is 4,200, and then 1, it decreases, so it's going to be a decay, so we mean minus. We got to change 10% to a decimal, which is 0.10 or just 0.1 to the power of x. Then when it says estimate the value of the snowmobile and after 3 years, we can simplify this equation. So it'll be y equals 4,200. 100% minus 10% is how I like to think that is 90%, or 0.9. If you want to put 0.90, you can. You can just put 0.9 if you want. Okay, to the power of 3. Again, we can just put that in our calculator. Okay, 4,200 parentheses 0.9 okay, technical difficulty, 4,200 parentheses 0.9 to the 3. Okay, so again, we could just put that in our calculator, 4,200 0.9 to the power of 3. Just put in exactly how it looks. Hit enter, and we get 3,061 and 80 cents. So 3,061 and 80 cents. Okay, pretty easy formula, pretty easy setup. Okay. Okay, compound interest. Okay, really useful in the real world. Compound interest is an exponential function. The amount equals the principal, which is what you start off with, parentheses 1 plus r, which is the rate, divided by n, which is the number of times you compound it per year, to the power of n times t, which is the number of years. Quick cheat sheet here. N equals 1 for yearly, 4 for quarterly, 12 for monthly, weekly is 52, and daily is 365. So you know how many times compounds per year based off of that, whether it's yearly, quarterly, monthly, weekly, or daily. You deposit $4,000 in an account. Okay, you deposit $4,000 in an account that pays 2.92% annual interest. Find the balance after 1 year if the interest compound at the given frequency. Okay, so it's going to be a different formula for each one of these. For the first one, quarterly, it'll be A equals 4,000 parentheses 1 plus the rate, which is, you got to change to a decimal, so 0.0292 over the number times compounded, which is 4, to the power of the number times compounded, which is 4 times 1, because the number of years is just 1. Okay, so all these are going to be the same except for that 4 is going to change depending, because it's going to be compound different amounts. When it's daily, it's going to be 365. So everything's going to be the same except for now instead quarterly 4 is going to be 365, and then 365 times 1. Okay, and then monthly is going to be 12. Let me change colors anyway. So we got 1 plus 0.0292 divided by 12 to the power of 12 times 1. So each time, the only thing that changes is the number of times compound. All of these you could just plug straight into your calculator and you will get the right answer. All right, figured I need to start charging the Moby pin before I start doing this, okay? So all these I could put in the graphing calculator. Let's do the first one. What was it again? It was 4,000. So 4,000 parentheses 1 plus 0.0292 divided by, what was the first one? Quarterly, so 4 divided by 4 parentheses to the power. What's 4 times 1? Well, it's just 4. Okay. So that'll be your first answer. When it's compounded quarterly, it's 4,118 and about 9 cents. Okay. So 4,118 and 9 cents for the first one. Okay. Then we go to the next one. It'll be to 365. So same thing pretty much. We could just 4,000 1 plus 0.0292 divided by 365 parentheses to the power of 365 times 1, which is 365. Okay, hit enter. You see that this one is pretty much similar, except for now it's 52 cents instead of 9 cents. So hopefully you can see that's 52 cents. That is, I'll just write it again. That's better. Okay. And then the last one. Okay, we just do it again. All right. Except for now it's compounded monthly. Is that right? Yes, monthly. Okay. So 4,000 parentheses 1 plus 0.0292 divided by 12 to the power of 12. and that is 4,118 and 38 cents. So 38 cents, same thing except for 38 cents. Okay, so that's pretty much it. You can see that you can make the conclusion that the more you compound, the more money you should have. And there's actually a formula we'll learn later called compounding continuously, which actually gives you the most amount of money for doing that. But daily is more than monthly, and monthly is more than quarterly, but still, it doesn't change much per 1 year. It's just a few cents. Okay, so you exit, deposit $500 in an account that pays 3% annual interest, compounded weekly. Find the balance after 5 years. Okay, just use the same formula to solve that. If you have any questions, email me, and that is it.